Hey everyone, and welcome to our capstone exhibition demonstration video. As we can see, we have a model of our Umbo EB300 smart beacon. As we can see, our device is currently offline and is reflected on the mobile app as well as the desktop app as well. It both says that our device is currently offline. So let's launch the application. I'm going to run the Python script right now. And as soon as I launch the script, we can see that our device status has turned online, both on the desktop app as well as the mobile app. As we can see, the LEDs have also lit up on the beacon as well. So the first feature that we want to show you is the actual beacon LED itself. So we can actually turn on and off the LED beacon using the app or the mobile app. And it reflects on the model beacon as well. We can see the LED is turning on and off. The next feature that we have implemented is license plate recognition. So we have a button here that is used to capture accidents, and once you hit the button, it shows a message saying that the accident capture is in progress. And now what it is doing is it's actually taking a picture of the surrounding. It's actually using ALPR image recognition to detect the license plate, and it's actually uploading that into the cloud. It's all done in the cloud, and once the process is done, we get a message saying the event has been recorded. So we can hit OK and actually go back into events and click on the latest event. As we can see, our GPS has been recorded along with the image of the surrounding has been recorded, as well as the license plate that was detected. So that's BFE J681, and that matches exactly what is placed on the sofa over there. So that is our license plate detection system. Another feature that we have implemented is object detection. So it detects objects that are in front of the beacon or in the surrounding area. So if I were to walk in front of it right now, it detects my presence over there. So this is done in order to also ensure the vehicles involved in the accident or whatever objects were involved in the accident. So it serves the purpose. So it's also, you can see the light turns blue when someone or something or some process triggered. The light indicating blue means that it's actually communicating with the cloud. So this is capturing the distance and it's actually uploading to the cloud. We also implemented the RFID sensor. So this enables the first responders to actually authenticate whoever is in the premise. So whoever has RFID tags with them, they can actually scan the sensor. So I'm gonna scan my RFID tag, and it flashes blue, indicating that it's actually communicating with the cloud, and it registered my RFID tag entry. So let's go back into the app and see exactly what the sensors are reading. So if I hit on sensors, we can see that there's two options, RFID and distance. If I click on distance, you can see that all the object detections were recorded on the app. And if I were to go back into the RFID readings, we can see that two readings were read. These were both when I scanned the tags. Not only on the app, but also on the desktop app, we can actually see all of these recordings. So if I click on the event and click on view, we can see that the GPS has been recorded, as well as it shows a GPS Google Maps. It shows the panoramic image along with the detected license plate, along with the RFID readings and the distance readings. A quick story on why the second image looks a bit crooked. As we can see, it's crooked, and this is because after we assembled the cameras, one of the cameras dislocated and it actually turned in a 45-degree angle. So we were not able to disassemble the model and fix the camera. But it serves its purpose, as we can see that it scans the image and it detected the license plate from that image. So it serves the purpose. So the next feature that we have implemented is actually temperature readings. So if I were to go back into our beacon, we can actually launch a new event that says crowd control. So if I launch that event, it's going to do the exact same thing as the accident capture. It's going to scan the surrounding. It's going to take a picture, record the GPS coordinates, and upload to the cloud. It doesn't do the ALPR image recognition this time because it's not for accidents. Once the capture is done, we can press OK, and we can go back. We can actually go and scan our wrist. And if I scan my wrist, it actually blinks blue, meaning that it's actually communicating with the cloud and recording my temperature to the cloud. So this is useful for the current global pandemic. In order to restrict people entering the premise, it serves as a safety purpose and limits the number of people entering the premise. And if I were to hit on temperatures, we can see that the temperature sensor has recorded all the temperatures of my hand. As we can see the temperature recorded as 38.05 degrees. We also get other readings. That's the readings from the surroundings when I move the hand away from the sensor. So it's not completely accurate, but it still serves the purpose. So this is our demo for our Umbo Beacon EB300. Here's the EB300 at night with flashing lights. It's also covered with reflective materials to better represent the actual beacon.